Hi, Algebra 2. This is Unit 2, Lesson 7, and today we're going to talk about transformations and parent functions. So, what is a parent function? Functions that belong to the same family share key characteristics. The parent function is the most basic function in a family. Functions in the same family are transformations of that parent function. So you did a little bit of this in algebra. We're going to look at the graph just because it's a nice easy one. Y equals the absolute value of x on the graph below. State the y-intercept and the vertex of the graph. So now we can do this in our graphing calculator, but remember, if y equals the absolute value of x, basically when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. When x is negative 1, the absolute value of negative 1 is positive 1. When x is negative 2, the absolute value of negative 2 is positive 2, and so on. So we get this v. Okay, and this is the parent function. This is the basic one. This is the main one. The vertex of this graph is 0, 0. That's sort of like that turning point. See how it's decreasing, and then it hits 0, 0, and it goes back up. That also happens to be my y-intercept, or y equals 0 is the y-intercept. Now remember, my domain, those are the x's, and when I'm trying to find my domain, I look left, right. So the leftmost point, there is no leftmost point. It goes from negative infinity, and the rightmost point, again, there is no rightmost point. It goes on forever and ever, and that's positive infinity. Remember, with infinity, I use parentheses in that interval notation. The range are my y's, and I look up, down. The bottommost point is 0, and I am including 0. And the topmost point keeps on going forever and ever, and that's infinity. Okay, and you can put these in your graphing calculator. I will do that for the next one because I want to look at f of x plus k. So I want to graph the function below on your calculator and describe the family of absolute value functions in the form f of x equals the absolute value of x plus some number. So now I'm going to take that absolute value and I'm going to add on a number to that. So I'm going to look at f of 1 of x, that's just the parent function, the absolute value of x, the one I did up above, and that's already drawn on the graph for us. And then I'm going to look up f2 of x, which is the absolute value of x plus 2. And I'm going to see what happens. And then I'm going to do a third one, but this time I'm going to do absolute value of x plus 5. And then I'm going to do a fourth one, absolute value of x minus 3. And I'm going to look at all those graphs together and try and figure out what's happening to them. So if you don't have a graphing calculator, you might want to get one on your phone or your computer. A nice one that works on a lot of phones is this Calculate 84. It looks really similar to your the TI-84 that you've used in class before. So to do this, I go to y equals, and I already put in my absolute value. Now, how did I get my absolute value? Let me clear this and start over. So I hit the math key, and then I go 1 over to the right, and I will have my absolute value is number 1 right there. So I have the absolute value, and then I put in my x. Okay, so that's the first one. If I look at the graph, and this is a little distorted, and it's not quite like how we look at it in class, but it's good enough for us. Let's look at the second function, the second graph. This time I was doing the absolute value of x plus 2. So again, I hit the math key. I go 1 over, absolute value, x. Now just make sure you hit your arrow button to get out of the absolute value, plus 2. Let's look at the graph and see what happened. Oh, so the blue one is the parent function, that's the original. And then this next one, when I added 2, it just shifted the graph up 2. So now for number 3, if I do the same thing, but this time I'm going to add 5. What do we think is going to happen? And again, I have to hit that arrow key to get out of the absolute value. I hit plus 5. Up, and that's the red graph. I went up 5 this time from the original parent function is the blue one. And what do you think would happen if I did the absolute value of x. So again, math key, absolute value of x, get out of there, minus 3. Well, let's look at it. That's going to be my, that's that pink one. I shifted down 3. So basically, when I have that graph of f of x plus k, that results in a vertical shift. So this is a vertical shift, up or down. So basically that's a translation. We talked about all of this in geometry last year. It's a translation. If it's addition, I'm going to go up, and if it's subtraction, I'm going to go down. Just to write some notes up here about what happened. So when I did x plus 2, look at the graphs, what changed? It moved up 2. When I did x plus 5, what happened to the graph? It moved up 5. And when I did x minus 3, I moved down 3. Okay, so the first one looks like this. I just went up 2. The next one was 1, 2, 3, 4, 5. It went up 5. Just doing a little sketch of these, nothing too fancy. And the last one I went down 3. So anything that's f of x plus k is just a vertical shift up or down. Well, let's try the second one, family of 2. So this time it's f of x minus h. Oops, let's get this. Okay, so let's see what's happening here. So I'm still going to start with this absolute value of x, that's the parent function. But then I'm going to do absolute value of x plus 2. So the 2 is going to be in the absolute value. So I'm really just using the same numbers that I used up here, but this time the numbers, the 2, the 5, and the negative 3 are going to be in the absolute value. So let's get my calculator out and see what happens when I do that. So here's my calculator, and the first one is great. Let's fix this one. Let me just see if I can delete that. I just clear the whole thing, that might be easier. So I'm going to do absolute value of x plus 2. And this time it's staying in the absolute value. Let me get rid of this one, and let me get rid of 4 too, just so I can see what's happening. So I hit the graph. The blue one is the parent function, that's the absolute value of x. Now look what happened, this black one, I shifted over. I was doing the absolute value of x plus 2, so you can see the whole graph shifted over to the left. Now this one's important to note because I was doing plus 2, but yet it shifted to the left. I would have thought that it would have shifted to the right, but I don't, it's the opposite. Let's try the next one. So I have the absolute value of x plus 5. Let's see if it's also shifting to the left. So I look at my graph right there. Oh, yep, that's the red one. So now I shifted to the left 5. And then I wonder what happens if I have the absolute value of x minus 3. What's going to happen? So I got absolute value of x minus 3. And, oh, that's that pink one. And it shifted to the right 3. Okay, so let's take some notes on that. So basically, this is a horizontal shift. I'm going left or right. It's also a translation. But remember, this is a little bit different. A positive number is a shift to the left. And a negative number is a shift to the right. It's the opposite of what you might have expected to happen. Okay, so right here, if I had the absolute value of x plus 2, it's a shift of 2 to the left. Absolute value of x plus 5 was a shift of 5 to the left. And the absolute value of x minus 3 is a shift of 3 to the right. Okay, so basically, if I start here, it looked like this. That was the absolute value of x plus 2, x plus 5, 1, 2, 3, 4, 5 was here. And the last one, absolute value of x minus 3 shifted to the right, like this. Okay, and those are my graphs. All right, let's try a few more. I'm going to stick with that absolute value graph, but this time I'm taking some number and I'm putting it in front and I'm multiplying it by the function. So graph the functions below on your calculator. Describe the family of absolute value functions of the form f of x equals a times the absolute value of x. But it's important to note that a is greater than 0. So a is going to be a positive number. Okay, so looking at my graph, get my calculator, go to y equals. So I'm going to leave that first one. I'm going to get rid of these guys. And then I'll come right back up here. So I have 2 times the absolute value of x is that first one. 2 times the absolute value of x. Okay, that's my first one. Let's see what happens. So my parent function, the regular one, is the blue one. And now I'm looking at this, is the black one. So you can see I kept the same vertex of 0, 0, but this is getting a little bit steeper. It's getting a little bit narrower when I multiplied by 2. Let's see what happens when I multiply by 5, because that was the next one. So 5 times absolute value of x. And let's see what happens to it. That's the red one. It's getting even narrower or steeper. Let's see what happens when I multiply by a fraction. So I got 1/2. So I'm just going to put that in the calculator as 0.5 because you know that that's the same as 1/2. It's a little bit easier. And absolute value of x. And let's see what this one is. That's the pink one. This one got wider. So basically when the number was greater than 1, it got narrower, steeper. When the number was less than 1 but greater than 0, it got wider. So this is, if you remember back from geometry, that transformation is a dilation. All right, so this is a dilation. That's what's happening when I multiply by a number in front. It changes the slope or the range, the rate of change. So it's changing the slope or rate of change. Basically, when a is greater than 1, it got steeper. And when a was less than 1 but greater than 0, so when it was a fraction, it gets wider. All right, so this first one, when I multiply by 2, it gets steeper or narrower. All right, when I multiply by 5, it gets even more steeper or narrower. And when I multiply by 1/2, it gets wider. Okay, so the first one got a little bit steeper. The next one, when I multiplied by 5, it got even steeper or narrower. And when I multiplied by 1/2, it got wider. So those are all dilations. All right. What happens when I am still multiplying, but this time a is less than 1. Less than 0. So a is less than 0. So basically a is going to be a negative number. So if I'm looking at this first one, well, the first one's the parent function, but now I'm multiplying by negative 1. Then I'm going to multiply by negative 3, and then I'm going to multiply by negative 1/2. So let's look at our graphing calculator to see what happens, and then we'll do like a little summary. All right, so coming back here, we're going to get rid of everything but the parent function. All right, and the first one I had negative absolute value, so here's my negative. So my negative, and then I have math, absolute value of x. Let's see what happens. So look at the graph. So the original one, the parent function, is blue, and now this is basically upside down. Okay, so I reflected it over the x-axis. But it did not seem to get steeper or wider or anything like that. But what happens if it's negative 3 absolute value of x? All right, let's look at this one. All right, so now it's red. It's still upside down, but it's getting a little bit steeper. It's getting a little bit narrower. And y equals, we'll do that last one, negative 1/2, so negative 0.5, and then absolute value of x. And we'll look at this one. Think about what you expect. All right, so that's the pink one. So it's still upside down. You reflected it, but now it's getting narrower. So it's similar to what we did right above in the third example. Okay, but the negatives have now made it upside down. So this is upside down. It's a dilation and a reflection in the x-axis. Reflection in the x-axis. So the first one was the parent function. Remember, negative absolute value of x, it was just upside down. That looked like this. Didn't get wider, didn't get narrower, just completely upside down. The next one, the negative 3, it was upside down and steeper. Okay, so it looks something like that. And then the last one, I'll leave it pink also. Negative 1/2, it was upside down from the negative, but the 1/2 made it wider. So it looks something like that. Okay. Let's look at a summary of all of these transformations that we looked at. So basically this negative sign right here, that negative sign is a reflection in the x-axis. The dilation comes from that A. So the A is a dilation. If you're multiplying, so the A is in front of that absolute value, I'm multiplying by A, and multiplication, just like last year in geometry, was if you had a dilation, you multiplied it. If A is greater than 1, it got steeper. And if A was less than 1 but greater than 0, it got wider. All right. Let's see. When I have this, when I subtracted by H, that was a horizontal translation, but it was backwards. Remember, I went left if it's positive. If it's positive, I go left. If it was negative, I went to the right. But it was a horizontal transformation. And then my last one, K. So if I added on something, that was my vertical translation. That was like normal, typical. If it's positive, I went up. And if it was negative, I went down. Okay, so we're just going to try a few on the next page. All right, number 1. What transformations are performed on y equals absolute value of x to transform into the graph y equals absolute value of x plus 4 minus 2? So when this number right here is in the absolute value, that's a translation left-right. Since it's positive, that's the one that's backwards. It's a translation of 4 to the left. And then that number that's not in the absolute value, that's a translation up-down. So I'm going translation 4 left and 2 down. What are the coordinates of the vertex? The normal vertex for the parent function is 0, 0. So my new coordinates are going to be negative 4, negative 2, because I'm going 4 to the left and 2 down. All right, what transformations are performed on y equals absolute value of x to transform into the graph y equals absolute value of x minus 1 plus 3? So this negative 1 is a translation of 1 to the right, and this 3 is a translation up down, right? So this is up down, and if it's positive 3, I'm going up 3. What are the coordinates of my vertex? The parent function is 0, 0, so this of course would be 1, 3. All right, hopefully this is making sense. What transformations are performed if I'm going to have negative 2 absolute value of x minus 1 plus 3? Well, because it's a negative, you're definitely going to have a reflection over the x-axis. So that comes from my negative sign. And then my 2, I'm multiplying by 2. That would give me a dilation of 2. Okay, that's going to make it steeper. And then my last one, I have 2 actually. That negative 1 is going to be a translation of 1 to the right. Remember, negative 1 is left, right, but that's 1 to the right. Okay, that's that. And then finally, I feel like I'm out of colors here. That plus 3 is going to be a translation of up 3. What are the coordinates of the vertex? Basically, the reflection and the dilation are not changing my vertex at all. The only thing that's going to change my vertex is that translation. So my final vertex will be 1, 3, because I went 1 to the right and up 3. The reflection and the dilation don't change the vertex. Only the translation does. And last one, the vertex of an absolute value equation is 5, 8. What is the equation? Well, if it is going positive 5, that's left, right, that means that I am doing absolute value of x minus 5. And then the 8 is going up, down, that is plus 8. And that's my answer. Okay, and that was lesson 7.